Okay, so today we are going to start the topic list manipulations. We know how to declare a list, that is using this particular statement. When I say L equals to opening and closing square brackets, we declare an empty list. Now, if you just want to enter elements, in this list at runtime, so I normally say, like, I will ask simply user to enter how many number of elements you just want to enter. So using input function, I'll simply ask user to enter how many elements you want to enter, right? How many elements you want to enter. It will simply ask user that how many number of elements you just want to enter. And then accordingly, I'll simply make use of a loop for I in range. We can say n. It will simply go from 0 to n minus 1, right? And it will ask me n times that enter the elements. So I'll simply have a variable called ele, and it will ask you enter element. Enter element, right? And then we simply append this element using append function, right, to the list. So this way it will ask me to enter n elements, and we will simply keep on appending those element to the list. If you want to display, these elements, we have got two ways. One is using indexing, and one straight away, picking up one element at a time from the list. Okay, I'll just show you both the ways, right? So I'll say for I in range, the first one using indexing. So I'll say for I in range n. So it will go from 0 to n, and these 0 to n means 0 to n minus 1 indexing. And it will keep on picking up the element using L1 of I. So I will start from 0 to n, that means 0 to n minus 1. So every time, it's going to pick element from the list within that specified index and display it. So this is the simplest method how you basically, enter n elements and display those n elements, right? I'll execute it for you so that you will have a better idea. Let's say I just wanted to enter four elements. So I'll say four, I'll say 1, 2, 3, and 4. So you can clearly see after this, it will simply show you that these were the elements which you have entered in the list, right? This is one of the way. This is one of the way how you, display elements from the list. Now, if I say I just wanted to go with, the element without indexing, I just want to retrieve the element without indexing. For that, I will straight away say for I in L1. That means from here, one element at a time is going to be retrieved from the list and will be displayed. Right? I'll execute it for you. In this case, if I say I just wanted to enter five elements, so let's say 1, 2, 3, 4, and 5, and you can clearly see that five elements which I've entered will be picked up and displayed like this. So in this case, what exactly happens? It basically picks up the element based on the indexing. If I say I just wanted to enter four elements, the four elements will be entered in the list, something like this: 1, 2, 3, 4. Indexing will start from 0. We have entered four elements. That means the last index value will be 4 minus 1, that is 3. 4 minus 1, that is equal to 3, right? So if I say n equals to 4, that means it will go from 0 to 4 minus 1, and every time it will ask you to enter the element, and you append that element to the respective block, right? So first time, the first value is going to be appended here, the next one here, the next one here, and the next one here. Now using this, for I in range n, it's simply going to retrieve the element based on the index. The index number always starts with 0, right? So first of all, L1 of 0, the value which you have entered here, the L1 of 0, the element of this particular block is going to be picked up and displayed. I will get incremented by 1 automatically, because there's no, when you do not specify any index, that means it automatically assumes that the step is +1, right? So next step value is going to be will be there, and that is 1 in this case. And next element from that index is going to picked up and displayed, and so on, right? So it will go from 0 to n minus 1, because the value of n is 4. So 0 to 3 is going to pick each and every element which is there in the respective index. In this case, we don't deal with the index. We straight away retrieve the values from the list, one at a time, starting from the beginning, right? So we'll simply retrieve the elements. We'll simply retrieve the elements from the list, one at a time, and keep on displaying those elements, right? In this case, we haven't specified here comma end equal to space, and that's why the elements are basically been displayed vertically, right? If you want to display the elements horizontally, you need to make use of a keyword called end equal to, and then that specifier, you need to specify what actually, how do you want to differentiate these elements. So we'll say, let's say print I comma end equals to. If I say I just want to separate the element based on the space, so I'll say space. And if you want to separate them using comma, you can specify the comma as well, right? So I'll execute it for you so that you can see the difference. You may say I just wanted to enter 5 elements. So 1, 2, 3, 4, and 5. You can clearly see, the elements are displayed in horizontal manner, and each and every element is basically been separated by the comma. Okay. So this is one of the way how you basically input elements in a list and display them. Uh, Straight away, let's say I just wanted to search an element from the list. If I just wanted to search an element from the list, so obviously, first of all I need to do, I just need to enter elements. I just need to ask user. Every problem has got certain steps. Like every problem we talk about, it has got three basic steps. One is called input, one is called process, and one is called output, right? So question is saying, I'll just write it on the question here only. If I say write a program to enter uh, n elements in a list and search for a particular element using linear search. So in that case, the input would be like, I'll simply say, first of all, you just need to create a list. You need to ask user how many number of elements you want to enter. You append those elements to the list, and then ask user that enter the element which you wanted to search, right? Enter the element which you wanted to search. So using this, we have entered n elements. I've simply picked up the values, the code of segment from here. That is just how you enter the elements. You know now how you enter n elements in a list. Now here I'll say uh, num. There's a variable called num, let's say. I just wanted to search for this element. If I say num equals to int, num equals to int input enter element to search. Okay. We have functions which can straight away find it out whether the number is there in the list or not, right? But I just want you to make use of the programming, how you basically navigate through the list and check whether that element is there in the list or not. Okay, I'll go with the traditional method, and later on I'll talk about the functions, the inbuilt functions, which can be used in just a single line to find it out whether that element is there in the list or not, right? So here I'll say we have entered n elements, we have entered a number. Okay, I just want to find it out whether the number is there in the list or not. For that, I'll take a variable called flag as an indicator. So I'll say flag equal to 0. I'll make use of a loop. I'll say for I in straight away I'll say L1. I'll pick the elements like that, right? And I'll compare if I equals to num. If I equals to num, right? If it is there, I'll say flag equal to 1, say print the number exists, right? And then I'll simply come out of that because there's no need to go ahead the number found, okay, at that particular location. If you just want to specify the location, you can specify the location as well. Right now the question was saying you just need to enter elements in a list and search for a particular element. So you just need to go with the question. The question is saying you just need to specify that the number is there or not. You'll simply say number exists, that's all, right? And at the end of that you just come out of this loop, okay. And if at the end of this loop you just need to check this one also. If the value of flag equal to 0, that means this condition which we were looking for, right, this condition was never true. So I'll say print that number does not exist. Simplest method, right? So I'll execute it for you. This is the simplest one, and then accordingly, I'll first of all I'll execute it for you, and then I'll explain you the code one more time. That how exactly that output came. Let's say I just wanted to enter five, or let's say five elements. I'll say 10, 23, 45, 67, and 34. Enter element to search. If I say, let's say 45, it says number exists, right? Again, I execute it for you just to check whether the number is there or not. If I say I just wanted to enter five elements and say 1, 2, 3, 4, 5, and I just wanted to search for 9, it says number does not exist, right? How exactly it happens? Let's see one more time. You entered five elements in a list. You appended five elements rather, right? You ask user how many number of elements. You say five. Let's say 1, 2, 3, 4, and 5. Then this part has done their job. It will ask you like five times to enter element, and you simply append those elements in the list. This is L1. Now you created one block called num, and you ask user to enter the element to search. Let's say you say 5 or 9, let's say assumingly 9. Initially the value of flag is 0. There's an indicator. There is a variable called flag that will be used as an indicator. For I in L1 is going to retrieve one element at a time from the list and is going to be compare that value with the number, right? If this is equal, if the value which you have retrieved right now is equal to the number, right, it will say flag equal to 1. The indicator will get changed. It will say number exists, and it will simply come out of that, okay. So at any point of time when it comes out of this loop, this is the body of the loop. When it comes out of the loop, it will check the value of the flag, but the flag is 1 right now, okay. So this part is not going to be executed, right, because the value, the condition I equal to num was true, and that's why the value of flag was 1. And according to this, the value of flag equal to the condition flag equal to 0 will be false, and this part will not get executed. But if I say, after the complete execution of this loop, because right now we have got the entries like that. First of all, it will be compared. No matching is there. Go to the next one. There's no match, and it will keep on going like that. So all the elements will be retrieved and will be compared, and there's no match. So at the end of this loop, it will check the value of the flag, and the value of flag is 0. Why? Because the condition which we have specified within the loop is was never true. That's why the value of flag will remain 0 and will say the number does not exist. So this is how you basically internally how exactly the system works on these code of segments, and you just need to understand these exactly the same way, and it will be easier for you to for the rest of the questions, that how exactly system thinks, and accordingly you can plan it out what code of segment you just need to write it down. So I was talking about the input, process, and output, right? So this part is basically the input one. This is the input, right? We have asked user to enter the elements and the number. This is the processing. We are comparing the element. This is the processing part, and this is the result, whether the number is there or not, right? So this part, this is basically a simplest example of input, process, and output. And this is a simplest example of linear list where we navigate to each and every block in a list to check whether the element is there or not. Okay. So this is basically the linear list. There's some more questions maybe they're based on this linear search, whether the element, how you just need to specify the indexing, you need to specify that what are the occurrence of a particular number in the list. This question may be there, right? So I'll just show you how exactly we can do those type of questions as well. The question says that write a program to enter n elements in a list, write a program to enter n elements in a list and uh, count the occurrence of a number, okay, and count the total number of occurrence and count the total number of occurrence of of a particular number of a particular element of a particular using of a particular element using linear search. Write a program to enter n elements in a list and count the total number of occurrence of a particular element using linear search. ठीक है ना? In a list using linear search. So what all I did, I'll simply create a list, right? Ask user to enter n number of elements. Ask user enter the element to search. Instead of flag, I'll simply take a variable counter and initially the value of counter will be set as 0, right? If I equal to num, again, each and every element from the list is going to be retrieved, will be compared, and if the value of I matches with the number, it will simply say counter equal to counter plus 1. It will simply keep on incrementing the value for the counter by 1. So it will say counter equal to counter plus 1. Okay. At the end of that, that's all you just need to do. And at the end of this loop, you just need to check the value for the counter. If counter equal to 0, that means number was not there, right? And if it is not like that, if the value of counter is not 0, that means the value of counter is greater than 0. In that case, say print total number of occurrence of which number. You want to specify that, you can say num is C. Okay, so what exactly is happening? You have got a list. You entered few elements, 1, 2, 3, 4, 5. You entered few elements, let's say 6, 3, 5, 2, 1, and 9. You entered these elements in a list. Now this is the number which you just wanted to search. Okay, this is the number. Let's say you just wanted to search for 2, and let's say this is 2. Okay, and this is also 2, assumingly, right? Now each and every element is going to be compared. Initially, there is a variable called counter C. Okay, and initially the counter is set as 0. Now this element is going to be retrieved using this. For I in L1, this element will be retrieved, will be compared with this value. Is if there's a match, right now there's no match. Okay, it will simply go for the next one. Okay, and pick the next one. Now this is going to compare with this. Does it match? Yes, it matches. In the value of the counter is going to be incremented by 1. Initially the value of the counter was 0. Now it will become 1. Pick the next one. No match. Pick the next one. Yes, the match is there. Counter will get incremented by 1. Will become 2 now. Now pick the next one. No, there's no match. Pick the next one. Yes, there's a match. So if there's a match, that means this condition is true. The last value of counter, whatever the value of counter was, will get incremented by 1, will become 3 in this case, right? Again, it will go with the next one. The condition is false and come outside. If the value of counter equal to 0, right now the value of counter is 3, which is not equal to 0. So this condition is false. It will go with the else part and say the total number of occurrence of the number, whatever the number you have entered. Right now the number which you have entered is 2, right? It will say the total number of occurrence of 2 is the last value of C. The last value of C was 3. So it will say the total number of occurrence of the num is 3. 2 is 3, that way. I hope this part is clear to all of you, and I'll execute it for you so that you'll have a better idea. Let's say I just wanted to enter, let's say 10 elements, 1, 2, 3, 4, 5, 2, again, right? 6, 8, 2, 7. I just wanted to look for the element 2. So you can clearly see the total number of occurrence of 2 is 3, that way. And if I say I just wanted to, let's say I enter the value, 10 values and say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And if I say I just wanted to look for 67, it will simply say the number doesn't exist. The number does not exist. So this way we can find it out, the total number of occurrence of a particular number in a list, right? This is one way to find out the number. In this case, what exactly we can do? We can simply find it out that how many times that number was there in the list. But this process is a bit lengthier. Think of that, you've got millions of information and you just wanted to search for a particular information. And assumingly, if that information is not there in the list, so that means it will simply keep on picking up the element from beginning to end, keep on comparing that element with all the elements, and check, and at the end of the loop, it will say that number does not exist. There's another approach. There's another approach, to search the element, and that is using binary search. That is using binary search. Okay, I'll explain you binary search first, what exactly binary search is, and then I'll talk about uh, you know uh, the coding part of that. Okay, understand what exactly binary search is first, and then I'll write it down the code of segment for that. In binary search, there is a prerequisite first, and the prerequisite is that the elements which you have entered in the list should be in an order. That is the prerequisite. Okay. So let's say you enter the elements in a list, and the list elements are not in sorted. So before actually applying the binary search mechanism or the technique, you need to sort the elements using, you can simply make use of the function called sort, which will simply sort the elements, right? Because right now the focus is on binary search, so you can't go ahead with another function or another set of code of segments which will sort the elements first and then you apply the binary search, because the main focus is on binary search. That means you can use some additional functions, inbuilt functions, which will help you out, right? So the function called sort. Okay, if you want to arrange elements in reverse order, so you can say l1 dot sort, you can say l1 dot sort reverse equal to true. By default the reverse is false. That's why the element of the list will be arranged in ascending order. Okay, so that is the prerequisite. Now just understand what exactly the mechanism of that linear sort is, linear this uh, binary search is, right? If let's say we've got these many elements, 1, 2, 3, 4, 5, and assuming let's say we've got 6 elements are there. uh, Elements are like this: 6, 7, 8, 10, 15, and 17. If these are the elements, right? And I just wanted to search for a number. Okay, the mechanism says that you just need to go with the beginning. There's a variable called beginning. There's a variable called beginning, and there's a variable called end. We need to take two variables. One is beginning, one is end, and then we need to find out the mid. Beginning is 0, end is 0, 1, 2, 3, 4, and 5. Okay, the end is 5. End is basically the last index value of the list, and we need to find out the mid by simply saying beginning plus end by 2. So 0 plus 5 by 2. Okay, that is 5 by 2 means 2.5. The quotient value is 2. So this is 0, 1, 2. This will be the mid value for the very first time. Now we'll compare the value of num with the value of the L1 of mid. If it matches, if the value of this num equal to L1 of mid, there's no need to go ahead. Okay, but if the value of num is not equal to L1 of mid, that means two more conditions are there: the greater than or the less than. First of all, we'll go with the equal to sign, right? Only three conditions can be framed within two variables, right? Either it is equal to or greater than or less than. So if first of all we'll go with the equal to one, equal to is not there, we'll go with the greater than sign. The value of num is greater than this one. The value of num is L1 of mid. This is the variable mid which we have taken, right? Is the value of num greater than L1 of mid? If it is, if it is, these elements are already, lesser than this value, and this value is already been checked. That means there's no to point. There's no need to point. There's no point actually to take these element into the consideration. Okay, There's no point to take these elements into consideration, right? We'll simply shift the beginning, which was initially 0, we'll shift this beginning to mid plus 1. That means now we need to focus on these elements only. The end is here. If the value of num is greater than mid, L1 of mid, then only in that case. If equal to is not true, greater is not true, that means obviously that number will be less than L1 of mid. And if it is true, that means these elements are greater than L1 of mid. So these elements can be eliminated. We cannot, I mean, there's no point to take these elements into consideration. In that case, we need to shift the value of end to mid minus 1. Now, these are the elements which we need to take into consideration. So what exactly you have observed? You must have observed, if the value of num is not equal to L1 of mid, okay, in that case, the 50% of the elements are basically been eliminated at first, I mean that in attempt, right? So if for the very first time, if the value of num does not match with the L1 of mid, that means the 50% of the total elements will be eliminated. Think of that. If you've got 1 lakh information for the very first time, the 50,000 information will be eliminated. Next time, 25,000. Next time, 12,500. Next time, 6,750 elements, and so on. So the point is that at every step, if the value of the num does not match with the L1 of mid, every time the 50% of the element will be eliminated, and hence it makes the search faster. That's why the binary search is comparatively considered the fastest search technique. Okay, because in linear search it basically go from beginning to end. Okay, and it takes a lot of time. But when it you know but when you talk about to count the occurrence, then obviously there's no choice left except to deal with the linear search, because in that case we need to go ahead with from the beginning to end. Even if you just make use of the inbuilt functions, they works exactly the same. It goes internally, the things will be defined like that. It will simply pick the element from beginning to end, keep on comparing those elements with that, and if the number found, keep on incrementing the value of the counter by 1, and so on. Okay, so anyway, so this was the binary search, and now we'll talk about the coding part of that, right?